good afternoon. Hope you had a good day one of Cisco Live 2025 Melbourne. Welcome to this session on Catalyst SD-WAN. Like the session name suggests, it's a start here session, which means this is our first session you go to start your journey on Catalyst SD-WAN. We have more sessions on Catalyst SD-WAN, which will dwell deep into each of the specific areas that we'll talk about today, like security, cloud connectivity, troubleshooting, and so on, that you may be interested in. You can check the session catalog and register for that accordingly. So my name is Prashanth Raghavendra. I'm technical marketing from the SD-WAN technical marketing engineering team. It's a jam-packed session covering various things from why SD-WAN to all the solutions and capabilities that we offer in the solution. So maybe we do not have enough time to take in all the questions. So I encourage you to make use of this WebEx option to post any questions that you may have post the session. I'll be happy to take a look and clarify that for you. This is the agenda for the session. We start with why SD-WAN. Look at the architecture of the Catalyst SD-WAN. Then look at all the capabilities and features. It's going to be probably a lot of things if you're not familiar to SD-WAN, Cisco SD-WAN. But I would just go through everything, and then if you're interested in a particular area or a particular topic, definitely visit us at the demo booth in the World of Solutions or attend the other SD-WAN sessions to gain more information. And then, we'll look at the newly launched 8000 series secure routers, which are powering the edge or the sites that are forming the part of the SD-WAN fabric. And then at the last, we will look at what are the next steps you can take to continue your learning on the topic. So quick introduction about me. Like I said, I'm a part of the global SD-WAN technical marketing team based in Bangalore, India. And my focus areas are user and application experience, operational simplification, and also analytics and AIOps, which is part of our larger assurance solution. Speaking of experiences, this is my 4th time in Cisco Live Melbourne. I love visiting Australia. I have explored over 6,000 kilometers of this country, mostly on the countryside, on a Harley-Davidson motorcycle, traveling solo across the country. It's been a wonderful experience. So let's start with why SD-WAN. So the classical based approach to wide area networking will not meet the needs for modern day wide area networks. You have devices, users, and things connecting to different locations like private data centers or data centers, public clouds, and SaaS applications in modern day wide area networks. And the observability or the visibility into the performance of applications and the network itself in such a wide area network is also an important thing to have. And all this must be done very securely. So Cisco SD-WAN or Catalyst SD-WAN introduces the software-defined networking principles, SDN principles, into SD-WAN, into the wide area network, and this is what is called as SD-WAN. So what is software-defined networking? Software-defined networking basically separates the control plane from the data plane. On the router, in the classical approach, you have both control or the routing decisions and forwarding decisions being taken. This does not allow enough flexibility, lacks automation, and also does not allow something like an internet to be used as a main transport. You have to rely on expensive MPLS circuits. But with the introduction of software-defined networking, you get to separate the control plane from the data plane. That means all the routing decisions are going to be taken separately, independent of the edge device in a separate controller. And then you have only the forwarding decisions being implemented in the routing hardware. So what this does is allows more flexibility. You can have any form of transport as your WAN link, need not be expensive MPLS circuits, which will give you very good performance with all the SD-WAN capabilities. You can have multiple topologies in the same network, be it hub and spoke, full mesh, or whatever it is you want. It will also allow what is known as segmentation, which is nothing but virtual routing forwarding in Cisco terminology, or virtual private network in the SD-WAN terminology, which is basically separating all your routing tables from each other to implement secure routing for different use cases. For example, all your corporate employees may be in one particular virtual VPN network, and your maybe PCI transaction could be in another network. Your finance could be in another network. So this is one of the key strengths of Catalyst SD-WAN, which will allow you to segment these individual functions securely so that they do not interfere with each other. If you wish to, you can still enable routing across these VPNs so that they can talk to each other. So with that, each segment can have its own topology. You can have, for example, hub and spoke topology in one, for example, in a finance kind of VPN, or you may have full mesh topology where all the devices are connected to each other in a, say, a corporate VPN. So this is one of the key benefits SD-WAN provides. Additionally, it provides a single GUI or a pane of glass to monitor everything, and that brings in the additional visibility and assurance capability. And it also brings in a lot of security functions, whether it's on-box or cloud security, that will help you to do all this very securely. Another benefit is you can do direct internet access. In these days, enterprise networks need access to cloud and SaaS applications, and it forms the essential day-to-day activity in any enterprise. So optimizing the experiences to SaaS applications and cloud workloads is very important. With the direct internet internet access that is possible in the SD-WAN, you have optimized access to SaaS application and cloud workloads. And all these are powered by our series of 8000 series secure routers, which are very powerful to realize all your SD-WAN functions securely. I'll skip this slide. So what are the common use cases for SD-WAN? Secure branch connectivity. Security is very important in today's world. I'm sure in APJC and Australia and New Zealand as well, it's a very important feature for all wide area network customers. So this SD-WAN offers you a secure branch connectivity. Multi-cloud connectivity. Connecting to cloud workloads, SaaS applications is all very important, be it your AWS, Azure, Google Cloud, and so on. You can extend your SD-WAN fabric or connectivity from a branch to the cloud workload very easily, completely automated in a few steps using the SD-WAN Manager GUI. And another important thing is you can use any form of transport. So you need not stick to your expensive MPLS or lease lines anymore. You can use the cheaper option or more economical option of internet, LTE, or any other form of transport, including Starlink as well, with SD-WAN to extend your wide area networks. And of course, it's secure and flexible with different features like DIA, direct internet access, all security features either on box or in cloud security. And it's a very scalable solution for any wide area networks of any size, be it a few sites or be it hundreds of sites. And it's feature-rich with various other options like L2 VPN connectivity over your SD-WAN networks. You can have WAN optimization for remote areas where you have a poor WAN connectivity with high loss, latency, and jitter. You can use optimization capabilities that we have to get a better performance for all your network and applications. And several other capabilities which we'll talk about in the next slides. With that introduction, I will get into the architecture. If you have any questions, I would suggest we take it up at the end since we have a jam-packed session, but if it's something that you really want to ask now, we can have a look at it. Otherwise, I'll continue. So coming to the solution overview, what are the components that make up Catalyst SD-WAN? So we have 4 clear planes which contribute to different functions. At the top, we have the management plane or the orchestration plane, which are two different planes, and I will go in detail. And then we have the two important control and the data plane, which is what we were talking about when we said software-defined networking. Coming to the management plane, this is the SD-WAN manager GUI. In case you are familiar with the earlier terminology, it used to be called as vManage. And with the rebranding, we are calling it SD-WAN manager. So this is a single pane of glass for all your day 0, day 1, day 2, and other days deployment. It can be a multi-tenant GUI as well, wherein with a single instance, you can host multiple tenants, typically used by managed service providers to save costs with the hardware and use the same instance to support multiple customers. And all these are clearly separated and secure. Then, of course, we can do centralized provisioning. Because the control plane is now separated from the data plane, all your controlling decisions, your business intent policies can be changed in one location on the controller and pushed to several of your sites at one shot. So a bulk or centralized provisioning. It makes the network agile, very reactive to business needs, and you no longer have to go to individual sites and make changes. For example, if you want to change the topology, all you do is change the required routing in the controller and push it to the devices. Then you have troubleshooting and monitoring capabilities, everything on the GUI. If you still want to use the CLI and if you're comfortable with CLI and still want to use it, that is possible. But you have everything on the GUI, like a control operations center. You look at it, all the like you might have seen in other presentations, green, red, amber, indicating different status, health, and so on. So it's very easy to consume with your GUI dashboard. Then you can do things like complete lifecycle management, software upgrades, patches, and so on. You can also get advisories and vulnerability information from Cisco whenever it's published on the dashboard itself, and you can take action to upgrade or patch it. Then it's also programmable in the sense we expose REST APIs on the SD-WAN manager, so you can do complete automation, build your own tool or build your own dashboard using these APIs as well. And just to mention, it's scalable as well, depending on the number of sites you want to support. A single instance supports some few hundreds of sites, I think around 2,000 to be exact. And then you can add more instances to support a larger scale deployment. Next is the orchestration plane. Sometimes both of them are talked together, but there's a clear component which will help realize this. It's called the validator. The goal of this validator is to generally orchestrate the entire fabric, bring up individual devices, help them to connect or join the fabric by providing the right information, authenticating it, and the whole thing is done very securely with secure connections as well as authentication like TPMs or the hardware devices and some kind of an ID verification for the virtual routers and so on. So the security is inbuilt everywhere, right from devices joining the fabric all the way till your actual traffic enabled with security features. This is the component that will supply the list of devices that are authorized to join the fabric. So whenever you buy the edge devices from Cisco, these are part of an authorized list, and you can upload those lists to this validator, and only those devices are able to join the fabric. So that way, security is implemented there. Also, this will act as a stun server, which will enable the NAT traversal. Suppose your device is behind a firewall, in which case, when it tries to connect to the validator to join the fabric, it will expose its NATed IP, but the validator knows that it's behind a firewall, and will share both the public and the private IP back to the device. And then the device can use this to join or make connection of the data plane to other devices. And so the validator acts as a stun server. Next, we come to the control plane. So this is the actual controller that implements all your routing control over the complete fabric. So this will disseminates the routes, the topology, and various other information, including IPsec, tunnel keys, and so on, to all the edge devices in your fabric. And you can implement any changes, business intent related changes to topology, or maybe routing decisions, or service chaining, and so on, all on the control plane. Then finally, we have the data plane made up of all your edge devices or the routers, which will give you the actual SD-WAN network. And this will establish secure connections with your control plane, and using what is known as OMP, Overlay Management Protocol, which is a Cisco proprietary protocol for the control plane to data plane communication. It also exports different performance metrics from the edge devices back to the controller and then to the GUI or the SD-WAN manager, so that you are able to get information about your network and see it on the dashboard. And we support what is known as zero-touch deployment, which means as soon as you power on your edge device, newly bought edge device, and there is a WAN link with a IP assignment DHCP server, it will automatically call home to the validator IP. We have a particular URL there. And then the vBond or the validator will get to know of this device and starts the onboarding process. So it's zero touch. As soon as you power on, it will establish connections to all the control components and to other edge devices. And we also have an analytics component as part of the overall solution, wherein significant amount of data from the network is accumulated. It's a cloud-based service. I think we're also thinking of an on-prem solution as well, but at the moment it's cloud-based service, wherein you have all the data coming in from the network, collected in a bucket, and then this is used to analyze historical trends, predict future performances using AI capabilities, and giving you various other information which will help you to get complete visibility into the network and application performance. And one of the key things about Catalyst SD-WAN that it can be on-prem or cloud-hosted. So there are a lot of customers or organizations across the globe who would want an on-prem solution. They're not comfortable having something in the cloud, for example, all the control decisions in the cloud, and they want everything to be on-prem. This is very typical of military, government organizations, or banking and financial customers who typically want this requirement. Catalyst SD-WAN supports all this without any problems. We also support air-gapped networks, wherein we have no connectivity to the internet. Everything is done using an MPLS circuit with no exposure to internet. A little more details on the various deployment models. It can be primarily three categories: either the customer or an MSP-hosted model, which is a complete on-prem model, wherein it's a little more effort on the customer or the MSP part. It can be Cisco-hosted. Cisco will host all the controllers for you. There will be a split management. Some things customer can do, some things Cisco will take care of, like patching or backups and so on, but there are something like upgrade, which the customer might have to take care of. Or it can be a cloud-delivered model, like a SaaS service, wherein the complete controller management is done by Cisco, and you can just use it like a SaaS service and onboard your devices, and your fabric is up. Different models are available depending on what is the requirement. So now we come to the capabilities and features. It's going to be, like I said, all the capabilities that we have in SD-WAN in a summarized way. And if you want to get more details on any topic, please visit the other sessions also at the World of Solution demo booth. We have various capabilities that we can show there. Some terminologies or design aspects that I want you to be aware of if you're new to Catalyst SD-WAN. We use a term called color and TLOC. TLOC is nothing but a transport locator abbreviated form. It is basically identifying an endpoint or a point on the edge device, it's like an interface from where you establish a data plane connectivity to other devices. And color is a kind of an abstraction, which is basically saying what kind of an endpoint is that and what kind of IP it has. Now, why this is important? Because we use this to create policies so that your routing and other decisions can be taken appropriately. And we also use this to set up the data plane tunnels whether it's going to be using public IP or private IP, and so on. So if you've defined a color, there are a set of colors which have been defined as private, another set called public. Depending on what is the color that you've defined, it will use the appropriate IP to establish those tunnels. A little more on the color part. Let's say you have two transport at a site managed with T1 and T2 as the two T-locks with two colors. And then you have T3 and T4 on the other vantage. And you have two links, right? And a public WAN link and a private WAN link. So T1 is defined with a public color, and T2 is also with a public. And T2 and T4 are defined with private colors. Now, I'd like to draw your attention to the diagram on the right side. By default, if there is no restrict option defined, T1 to T3 and T1 to T4 tunnels are formed. And the same for T2 to T4, T2 to T3. But if you want to restrict the formation of these data plane tunnels on the same transport, for example, T1 and T3 are both on the public WAN link, I want tunnel only between these two. I can use the restrict option, in which case the tunnels will be formed only between T1 and T3, T2 and T4. The T1, T4, T2, T3 tunnels will not be formed. This is one of the ways you control how many tunnels you want in the system, scalability, what kind of connectivity you want to allow, and so on. A quick note on the overlay management protocol, which is the protocol I mentioned runs between the control plane and the data plane for actual exchange of routes and various other topics, various other information. So this is a TCP-based extensible control protocol, very similar to BGP. And it runs between the WAN edges and the controller, as well as between the controllers, so that everything is in sync in terms of the allowed routes or the topology and so on. And it is used to exchange all the control information and also various other information like IPsec key-wise, pairwise key management, and so on. So this brings in the complexity of the overall network in terms of a solution scale, right? So that's the way Catalyst SD-WAN is able to support large scale. There are deployments wherein we have over 10,000 sites in a single fabric. Different kinds of fabric communication is possible. Let's say you have a site with two transports. You can set it up in an active configuration, wherein you have sessions and load sharing happening on both. Or you can have it as an active weighted configuration, wherein one link is given more priority, that is more traffic is sent to one link compared to the other link. You can also have application pinning on a particular link, which means you want all the flows from a particular application taking one particular WAN link. And you can also have it SLA based, which means I can define SLA, service level agreement metrics, loss, latency, and jitter, saying I want this % loss, this amount of latency, this amount of jitter to be met. If it is met, only then send the traffic on this link. Otherwise, do not just ignore the link. You can also have a single hop fabric, which means the two devices are exchanging data directly. You can have different topologies, or going to a hub and going to the site again. Or you can have what is known as multi-region fabric. This is relevant for a large organization which are like geographically spread, and you want to manage individual regional fabrics or networks separately from the other, but still want to manage the whole thing together. I have a slide on that. Look at it later. Yeah, this is the slide. So this is typically applicable for, like I said, large organization that is geographically spread, multi-country, multi-continent kind of thing, wherein you want to manage each of the regional networks in an independent way, but still have connectivity to the rest of the networks. So this is something similar to the BGP concept, wherein you have edge routers, border routers, and the border routers help to connect the fabric internally. So within the SD-WAN Manager GUI, you can define sub-regions and set up the controllers to manage them independently. So as you can see, Catalyst SD-WAN is a very scalable solution supporting huge deployments. Yeah.
Does that require dedicated offers for
So the ones that are called as border routers there, those are going to be kind of interconnecting the two networks. But you can say all my routers in Australia, for example, I will manage in a different way. I have different security, different cloud connectivity. All my routers in, for example, Japan, I will manage in a different way, but I still want them to connect. I mean, you can still manage with a single big fabric, but sometimes there are requirements from certain organizations, like I said, geographically widely spread, who want to manage this way. So in those cases, you get that independence while still being together.
But they're dedicated ones, right?
Yeah.
Not the branch router.
Yes, one router will be part of that one particular regional fabric. Does that answer your question, or was it something else?
Can it be a branch router as well?
Yes.
Can it do role?
Sorry?
Can it do both roles?
Yes, you can. So a single router can be part of one fabric, like an edge, but it can also be a border router which will connect to the other one, a single one, yeah. I'm not sure if that is very much a relevant feature in this region, but sometimes very large organization ask for it. Okay, so with that background, let's bring it up, all the capabilities one by one. So I mentioned zero-touch provisioning. Just to add a little bit background to this, you just buy a new router and you want it to join, it to be able to join the fabric. So all you need to do is power on. Let's say there is a DHCP server available which will supply the IP to the WAN link, and this will do a call home to the validator URL, which is predefined. And then the validator will get the information about the device. The two of them will authenticate each other using some encryption mechanisms. And then it will also look at the whitelisted set of devices, serial number, and so on. And it will ensure that this device is part of this organization fabric. It is allowed to join. If so, it will pass on the information of the manager to the device, and the device will connect to the manager. So it knows, okay, this is part of my network. I'm allowed to exchange, connect this to the fabric. And then it will pass on the information of the controller. So it's a stepwise thing. And the controller, when the device talks to the controller, it will set up the control plane, and you'll get the information about all the controllers and devices that are part of the network. And then you set up the data plane with all the other devices. At every step, authentication is done, as well as the whitelisting check with organization name and other fields to make sure this device should be joining the fabric. Any kind of thing at any point of this onboarding, if there is some problem detected, for example, if the serial number of the device is not part of the whitelist, the device will not be allowed to join the fabric. So you have that fabric security implemented completely in SD-WAN. Let's look at the fabric operation, a quick walkthrough through it. You have two WAN edges and having two transports, 1 and 2, and there is a controller. A very simple case, right? Just one instance of the controller and two WAN edges. So it will form the control plane connection. It can be a DTLS or a TLS tunnel, depending on the capability. And you have the OMP protocol, control plane protocol, running through this. Next, it will form the data plane connection over both the transports, right? With the transport 1 and the transport 2. And then you have what are known as BFD probes, or a BFD protocol running between the two. BFD, as you know, primarily is used for measuring performance and behavior of the link, right? Loss, latency, and jitter metrics are picked up by this. And these are used to say whether the link is performing well, match against SLA, predefined SLA configuration, and so on. So once the control plane and data plane are established, let's say you have defined a VPN1 in one of the edges, and the same VPN1 in the other edge as well, along with various other protocols. Now this is all relayed to the controller via OMP update. You will get things like reachability information with the subnets and TLOCs, all the security related things, like I mentioned, the encryption keys, and any policy related information. So the controller knows everything that is there on the edge. And let's say you add another VPN2, there'll be an OMP update mentioning the same to the controller. So OMP plays a critical part in ensuring the control plane and the data plane are always communicating together. And this ensures that the router is, or the fabric is ready to take quick actions whenever you define a new policy. Some points to note regarding the data plane privacy. I think I will skip some of these slides because we have several things to cover. But data plane privacy, in terms of key exchange, integrity with wherever there is NAT involved, automatic update of the AH value and packet integrity, and IPsec anti-replay protection using a sliding window mechanism. All these are mechanisms to ensure the data plane works well with no issues, even if there are like missing packets and so on. So like I mentioned, segmentation is a very important feature that SD-WAN offers in general, and Catalyst SD-WAN implements this with a very good architecture. So each of these VPNs or VRFs has their own routing table, which makes it possible to realize different kind of topology, different security, different policies for each of these VRFs independently. We have the VPN 0, or the VRF 0, for all your WAN-related traffic. That's the main thing where you connect all your WAN link. And then you have the VPN 5 and 12, which is fixed for all your out-of-band management capabilities. All the other VPNs from 1 to 511 are available for your service side or the LAN side features, however you want to define, like I mentioned, right? In an organization, you may have corporate employees one, finance in the other, and maybe HR in the other, and so on. Or if you're a retail customer, maybe PCI transactions in one, in case of banking and so on. Another important feature that SD-WAN offers is optimizing application performance, right? And this is realized by having what is known as application-aware routing. So with an application recognition engine that Catalyst SD-WAN has, called as N-bar, we can identify, I don't remember the exact count, over thousands of applications with simple match of the packet headers. And I think in some cases, in the first packet itself, we're able to match. So this is an extensive database of all the applications, which is constantly updated with a cloud-delivered feed as well, if you wish to. And so we have the complete application information available. Using this, you can create policies to match applications and do whatever you want on them, like route them somewhere, block them, and so on. Right? And application-aware routing uses this to match the application and optimize the path that it takes to reach the destination. So basically, you start with defining a policy, application-aware routing policy, wherein you define SLA metrics, saying this application needs to have paths that meet this minimum SLA. And any path that does not meet the SLA, like for example, I have 4 paths, 4 WAN links, and I define SLA metrics, and the traffic is going, let's say, load balanced across all of them. Suddenly, one of the paths does not have the SLA met, and it starts behaving poorly. You don't want your application to be affected, performance, right? So you would automatically steer the traffic onto the remaining available paths and leave out the non-performing path. So that is how application-aware routing works. Automatically steers application to different paths whenever there is an SLA violation. Then, like I mentioned, what we have, what is known as application optimization or WAN optimization. Suppose you have a remote site wherein you have poor links, maybe LTE, maybe Starlink or something like that, wherein you have high latency, or maybe there is a high loss. You want to overcome these things. There are software-based optimization mechanisms that are part of Catalyst SD-WAN, which help you overcome these and achieve a better performance. What are these? Firstly, we have what is known as TCP optimization. This uses various things like congestion algorithm modification, window scaling, large initial window concepts, and selective acknowledgement. All are TCP-based concepts, which will reduce the latency that you see on the WAN links and get you a better performance. We have what is known as forward error correction and packet duplication. Like the name suggests, forward error correction is basically when you send a bunch of 4 packets, you send an additional extra packet. And if one of the original packets is lost, you will be able to use that additional packet, which is like an XOR combination of the 4, and recover the original packet. That's what forward error correction means. And then packet duplication is when you have multiple links, and the key thing is avoiding loss rather than worrying about bandwidth. You can send the same packet or duplicate it across multiple tunnels so that you use, if there is a loss, you can use the other packet, duplicate packet, to recover the data. Then we also have what is known as data redundancy elimination, which is basically a technique to replace longer byte patterns with shorter byte patterns and maintain a cache with the mapping of the two on both the sides so that you send lesser amount of data over the WAN link, thereby reducing the bandwidth, but you're able to dedupe on the other side and recover the original pattern. So this way, you get significant improvements in the bandwidth reduction, and that will result in increased throughput. In some of the deployments and test cases or under test some particular conditions, we have seen reduction of up to 90% with of the improvement of throughput by up to 90% with the enablement of TCP optimization and DRE. And all this can be simply configured and enabled using the SD-WAN manager in just a few clicks. Now coming to the security features. Like I said, segmentation is very important, and this helps you to realize a multi-topology network for various purposes. Each segment will have its own routing table. On the right side, you will see there are 4 different examples. In one segment, maybe you want to have a full mesh topology. That is, all your devices connected to each other with tunnels. On another one, you may want to have a hub and spoke topology. There is a hub site, and all the spoke sites connect to that. But there is no direct connection between the spokes. In another case, or another segment, you may want to have a partial mesh. Some sites are connected to each other, but some sites are connected only to the hub. Or you may have a point-to-point connection as well. All these are possible within the same network, different segments. So we talked about so many things SD-WAN helps you benefit from, but what about the security? So because the attack surface is increased with things like direct internet access and so on, right? You get more security challenges. What can you do, or what is available in a Catalyst SD-WAN to overcome these? So SD-WAN provides several on-box security features, and also supports a SASE implementation. That is, SASE is nothing but SD-WAN plus SSE, that is cloud security. You may have on-prem security with a thick branch and with routing and security implemented. That is, most of your security is implemented on box. Or you may have SASE solution. Cisco Secure Access is our cloud security solution. So you would have a thin branch, that means a light branch with most of the security implemented in the cloud. Or you may have a hybrid model. You may want to do some of the security on the box, some of them on a regional hub, some of them on a cloud security. So all kinds of combination are supported. So this slide is about security and the SASE solution that we offer, whether it's Cisco on Cisco. First to start with, it can be on-prem or cloud. In cases of the Cisco SD-WAN devices having more than 8 GB of RAM, you can have what are known as containers that can run and implement these security features. What are these security features? Next generation firewall, right? You can have L3 to L7 based app recognition for the and user identity as well for your security policies. Intrusion prevention system, intrusion prevention, detection as well as prevention. Cisco has a company called as Talos, which is a signature company, malware signature company, and it's a huge database that is constantly updated, and it has several malware signatures. So the intrusion detection and prevention system basically compares the traffic against any of these signatures present and will flag that as an intrusion detection. We have URL filtering capability. You look at the URLs that are being accessed, and you have a policy to either block it, allow it, inspect it, log it, and whatever is required. Then advanced malware protection. This is basically using a ThreatCrit sandbox, wherein when you want to download a file, you do not open it right away, but you have a sandbox wherein this is open, so the rest of the infrastructure is not damaged. And you open the file and see whether it behaves fine or if it's any known malicious signatures are detected. If it opens fine, then you allow the actual file opening. If not, you categorize it as a malware and you do not allow the user to open it. Then you have SSL proxy. So most of these days, the flow of the traffic flow is all about all HTTPS or TLS-based traffic, in which case it is encrypted. How do you identify the actual signatures in the packet? You have to decrypt it. So SSL proxy provides that mechanism to decrypt the packet, examine it, and encrypt it again. And finally, the cloud security or the SSE feature, which is our Cisco Secure Access. And that includes DNS security. That is, you basically check all the DNS requests and make sure they are authentic. Let's look at each of them a little bit more. Next generation firewall. This is, like I said, a stateful firewall. So basically, you have traffic exiting out and incoming traffic are all examined, and only the requests that have opened up are allowed to return back. And requests originating out of the box are not allowed to directly. We also have high-speed logging, basically like a firewall kind of visibility with 5 tuple information on the SD-WAN manager now. So all the security logs go into a large database, and you're able to view it in the SD-WAN manager. You can see what was the source IP, destination IP, ports, and which policy was it, what was the action dropped, allowed, inspected, and so on. Intrusion prevention and intrusion detection mechanism I already mentioned. So you can set up 3 modes for this: connectivity, balanced, or security, depending on what severity you want to measure these with the traffic. Then URL filtering, it's straightforward. In some cases, like hybrid security, you may want to do things like URL filtering on the box, but do more advanced security features in the cloud security. So you can use that option. For example, in a hospital, you may want to prevent searches for some specific sites, like abortion related or whatever, and maybe implement the rest of the thing in cloud security. Advanced malware protection, there are different components like I mentioned, but basically there is a database which will tell you what is the reputation of a particular file, what is the retrospection, that is after inspection, what was detected, whether it's still not a malware file or a malware file, and then the sandboxing analysis. TLS and SSL decryption, I already mentioned this. DNS security. So there is a local domain bypass for DNS security requests. That means if the DNS request is going to a local domain, you can bypass the security check. And it also supports the DNS script request. Final note on the Cisco Secure Access, which is our new SSE or the cloud security feature. I think this was shown in a couple of other presentations as well. You can have complete security, whatever you can do on box in the cloud now. And if you have more traffic going towards the cloud, you can use this to connect to your private apps, you can do your SaaS applications, any internet traffic, by combining SD-WAN and this, realizing a full SASE solution. But it doesn't end there. We also support, we also support integration of Catalyst SD-WAN with other third-party trusted vendors like Zscaler, Palo Alto, and so on. We have open API integrations with them, so that if you're already using a particular SSE solution, Catalyst SD-WAN can integrate with that directly. Or it could be the other way around as well. If you're already using a third-party SD-WAN, you can also integrate that with our Cisco Secure Access, easily realizing a multi-vendor SASE solution. Let's skip this. Yeah, so this was I was mentioning third-party multi-vendor SSE integration. Now coming to the cloud connectivity capabilities. Cloud on-ramp for SaaS is our branded name for optimizing connectivity to your SaaS applications. So SaaS applications experience are becoming very important for most modern enterprise networks today because you no longer have, for example, Office 365 running on your laptops. It's mostly a SaaS application. You need connectivity to that. So internet becoming a key transport link for your SD-WAN. The performance of internet circuits is sometimes unreliable. How do you optimize access to your SaaS applications in this case? For doing that, you need to get visibility. First of all, you need to know how the different paths that are being taken by the SaaS application traffic are performing. And then you want to know what is the issue that a particular path is having so that you can automatically steer traffic onto a better performing path. Let's take an example, right, wherein you have internet DIA, direct internet access, at a particular at a particular site, remote site, having two ISPs, ISP1 and ISP2. And let's say there is a loss and latency on ISP1. So we constantly send out HTTP probes on all the WAN links to determine what is the performance of the particular link. So using that metrics, you define how the particular WAN link is performing. And if you see a better score on another path, you would use that path to access the SaaS application. But what to do if you have a regional gateway? Let's say you have ISP1 connecting directly, but you have MPLS and then to a regional gateway and then ISP2 from there. So till the path from this side to the regional hub, you would measure it using the standard BFD probes that we have on the data plane. And the rest of the internet path you would measure using the HTTP probes. That way you'll get the complete measurement of the path, and then you decide which one to go for, whether to take the direct path or via the regional gateway. All this is automated and inbuilt in the Cloud on-ramp SaaS solution in the SD-WAN manager. And access to some of the most popular SaaS apps, I think around 14, is completely automated and integrated. Optimizations for custom apps are also possible. You can define custom apps with unique FQDN numbers, port numbers, and so on, and implement these optimization for that as well. Then Cloud on-ramp for multi-cloud, like connecting to a different cloud service provider or IaaS providers. So what are the use cases here? So key thing is SD-WAN manager provides a simple few clicks, easy steps to extend your SD-WAN fabric to any cloud site or to another site via the cloud backbone or to the cloud workload itself. So there are three different use cases. First thing is extending your enterprise site to a cloud workload. And the second thing is enterprise site to enterprise site over a cloud backbone. And the third thing is cloud to cloud or inter-cloud connectivity. In all these cases, SD-WAN manager provides an optimized API-based automation, which makes it easy for you to establish these connections. We'll take one example, extending SD-WAN into a public cloud. AWS is an example here, but we support all the popular cloud providers like AWS, Azure, and Google. So here you have a branch site at the bottom, and you want to connect it to an AWS VPC at the bottom right. So you do this by installing a virtual router of the C8000V, Catalyst 8000V, inside an AWS VPC, which works as a transit VPC. And then this would connect to an AWS transit gateway. And that gateway will manage the routing to the exact VPC. Here as well, you can have complete segmentation. For example, a particular segment on the branch site can map to a particular VPC in the same segment. So it's still isolated, still secure, end-to-end segmentation. And you can also use the AWS TG Network Manager to share telemetry data from the branch site to the AWS TGW Manager and vice versa. So you have complete telemetry exchange. You will get visibility whether it's in the AWS TG Network Manager or the SD-WAN Manager about how the connection is performing. So we mentioned Cloud on-ramp for multi-cloud, which is doing the complete automation to extend the connectivity to a cloud in a few easy steps. But you can also do your own automation with third-party tools like Terraform or Ansible. it would need a little more work. If you have a very specific custom kind of cloud infrastructure, you may need additional API automation, but it's still possible. But cloud on-ramp, multi-cloud should help you realize most of the use cases. Then there is the concept of middle mile optimization. Now, if you're not familiar with the term middle mile, you have these large core networks which which form the internet basically, and then you have your home or businesses local networks which need to be connected to this core infrastructure, right? So the first mile starts from the core networks, then comes to the middle mile or the infrastructure which will basically connect the global networks to your home or business networks, which will be the last mile. So whatever infrastructure is in between is the middle mile. Now, a simple ISP will provide you a simple internet connection that may be sometimes unreliable and so on. But there are organizations which offer you that middle mile optimized experience. We have close integration with Megaport and Equinix, which are two of the most popular middle mile providers. So you get subscription-based, like for example, Amazon Compute Resources is a subscription-based model, which will automatically scale. This is also very similar like that, subscription-based, auto-scale, on-demand use of the middle mile capability. So you'll get a very premium performing middle mile, which is subscription-based, which will help you realize better connectivity. And you can also use the cloud provider's backbone as a middle mile. So basically, you connect the two sites, enterprise sites, using the cloud as a backbone. And we have close integration with all this to help you realize different use cases. It gives you the flexibility to modify as required and purchase the middle mile as required. Reliability, definitely much better than a simple internet connection. And you can set up end-to-end security policies over this because it's all SD-WAN fabric extending everywhere. And it can be on demand, which will help you optimize the costs. So that's on the multi-cloud. Then on the assurance part, like I mentioned, we have analytics as a software, as a cloud-based service working with Catalyst SD-WAN, which gives you historical trends and insights into performance of the network and application. It will also help you to get extensive troubleshooting analysis and help with various kinds of rich insights like Sankey diagram, how the flows are going, how the QoS is performing. And with introduction of AI and AI getting into all our products, you have the adaptive and predictive networking. So instead of waiting for an SLA violation in application-aware routing and then steering the traffic, you predict that an SLA violation might occur and steer the traffic before itself. I'll come to the AI features in a bit. I'll skip this. Okay, so NWPI is Network-Wide Path Insights, is a powerful Cisco patented troubleshooting tool that is part of the SD-WAN manager. We have integrated this with different products like Cisco Identity Services Engine, ICE, which will help you get that user-specific insights for policies as well for troubleshooting. So you can say, for example, show me all the application flows originating from a user, John. It'll show you only those. This is possible because Identity Services Engine will provide you the user-specific information, and you match that with the traffic flows, giving you that insight. This is what I mentioned. You can view the complete firewall and next-generation firewall logs on the SD-WAN Manager dashboard. And then integration with 1000 eyes, which is also very important to extend, to have visibility into complete path, whether it's the traffic originating from your branch site all the way to another branch site or to SaaS application. Inside the overlay, outside of the overlay, complete visibility. And NWPI integration with 1000 eyes will give you complete visibility in terms of troubleshooting. You can pinpoint the exact hop, whether it's on the overlay network or the underlay, where maybe there is an extra latency added, or maybe there is a problem with the link. You can pinpoint exact point where the problem is occurring, and thereby conclude whether it's a network issue or an application issue. And there is also reports available on the SD-WAN manager and analytics, networking and security reports, which you can download in a PDF or a CSV format, maybe, and you can schedule it like an automatic run every week. For example, every Monday morning, maybe your managers wants to have a look at how the network and application performance has been. 9 a.m., send a report, this report, to your manager's email. Splunk is another important product from Cisco for giving you that complete visibility and information, especially for security events. We have an Cisco Enterprise app for Splunk, which combines logs or information and events from SD-WAN, Catalyst Center, ICE, and in future, maybe other products as well. So you have a complete view of all your data center, wide area networks, everything in one single dashboard. And there'll be some correlation as well, which will help you identify or troubleshoot issues and performance-related concerns. Coming to AI. So the AI ops basically is focusing on simplifying day-to operations, and Cisco is investing heavily in AI. You might have heard about it. And we are bringing in all various AI capabilities in all Cisco products, and SD-WAN is not far behind. So to optimize network and application performance, you have two things. One is predictive path recommendations, and the other is the generative AI assistant. Predictive path recommendation is basically what I mentioned. Instead of waiting for an SLA violation to occur and then steering the application onto a different path, using the historical data, you predict that there might be an SLA violation and then steer the application traffic before itself. AI Assistant for networking is a common, again, cloud-based service, which uses a generative AI model, a deep learning model, trained with Cisco documentation and other workflows, which will help you use this assistant for monitoring use cases, documentation fetch use cases, troubleshooting use cases. If you are interested in knowing more about any of these or demos, you can visit us at the demo booth. And then we also have AI built in other use cases. For example, forecasting what could be the usage of a particular WAN link capacity in the coming weeks. The capacity of your WAN links is very critical for your enterprise operations. Maybe one day suddenly the usage goes beyond a certain bandwidth, which you're not subscribed for, and the performance of several applications drops down, which can affect the business badly. So you will want insight into when you want to subscribe a higher bandwidth. This will help you do that. It will forecast that in the next few days or weeks, you may have a higher bandwidth required. Subscribe to the ISP right now. And detecting network anomalies. It look at various network performance parameters, again, like loss, latency, and jitter, and establish a particular trend. And if something goes away from the trend, it will identify or pinpoint you that there is something going wrong, it needs your attention, have a look at it. Because sometimes deviations from normal patterns indicate some anomaly, and if you do not look into it, it can cause some business outcomes to not go in your way. So these are the various things in which we are bringing AI. As you can see, predictive ways, generative AI ways, and also some forecasting ways for bandwidth and network anomalies. Coming to some of the operational simplification aspects. As you know, Catalyst SD-WAN is a very, like you've seen today, it's a very powerful and flexible set of features and capabilities that can help you realize any use case. While it can do all that, operational simplicity is also very important. Otherwise, it becomes very tough to manage, and you may have an issue with that. So we have simplified operations and improved the visibility and monitoring aspects on the SD-WAN management dashboard, as well as simplifying things like configuration, policy creations, and so on. We introduced what is known as a workflows library. Again, this is a common thing that you may see across all Cisco products. Basically, it's a set of guided steps, easy to execute on the SD-WAN manager. Let's say you want to do a software upgrade. It'll just take you through a couple of steps in which you can select the image you want to upgrade to, or maybe select the site you want to upgrade to, and so on. or you want to create configuration for a particular new branch. It'll help you create that in a few easy steps. You no longer have to be, for example, an expert in all the configuration of the router to be able to create a new site. Then we have introduced what is known as a configuration catalog. You can think of it like a Netflix-like movie selection that is hosted, validated by Cisco. You can simply browse through the catalog. If there is a particular configuration use case that you find useful to you, just download it and start using it. We have started with a few of them, and we'll be adding more to the catalog. And policies creation has been simplified as well. One interesting thing that I want to mention here is SD routing. This is nothing but using a GUI to manage your non-SD-WAN routers, that is your autonomous routers. You may have your traditional WAN networks like DMVPN or something, wherein you are managing all the routers individually in the CLI, but maybe you want to move to the UI. You can use the same SD-WAN manager, the same validator, same manager can be used to monitor and configure your autonomous devices, but there won't be any connection, control plane, data plane separation, so there is no controller. So you already are a step into the SD-WAN journey, and someday if the customer decides, I want to go to complete SD-WAN, it's very easy because they're already familiar with the manager and validator. All they need is to introduce a controller. So this is what SD routing is about. Using the same SD-WAN manager to manage your and configure your classical networks. So like I said, the difference is the control plane separation is not there. So you may be thinking, okay, so much of Catalyst SD-WAN discussion, what about Meraki? So Meraki is also definitely there, and it's one single SD-WAN now is how we talk about it, because there is now an integration of Meraki and Catalyst SD-WAN joining the two fabrics. So if you are a customer having a disparate kind of deployment, wherein you have some sites, simple use cases managed by a Meraki dashboard, and some use cases managed by SD-WAN manager, Catalyst SD-WAN manager, you may want to have still a single dashboard to manage the two. So for such deployments, you can use the Meraki dashboard for managing all the devices. What it does is establish a connectivity to your SD-WAN manager using APIs and have a single dashboard to manage the whole thing. So I'll just take 2 more minutes. Key takeaways. I will skip this. Quick note on the 8000 series routers. So we introduced these industry's most advanced router a couple of months back, which has inbuilt AI engines as well as post-quantum cryptography capability. If you're interested in knowing more about PQC, you can visit us at the demo booth as well, or put your question in the WebEx space. I'll be happy to answer that. And we have introduced a router for every size and location, from 8100 all the way to 8500. And simplified the licensing model as well. If you're familiar with the earlier model, this is much more simplified. I'll skip through this. You can talk more about it later. I have a demo, but I think we don't have time for that. But please do visit us in the demo booth if you need to look at it. Yeah, so that brings us to the end of the session. Sorry, I'm 5 minutes late. But yeah, please look at the session evaluation and complete it. You stand to win a gift or a prize for that. And if you're interested in attending more sessions on SD-WAN to get deeper insights into any of these, we have a security and SASE session, multi-cloud session, and also a troubleshooting session, and I think one more session coming up. So that's it, and please respond to the survey questions or give a feedback on the session. Thank you.